Students, we know light falls on all objects, and all of us know this thing as well, that we can see the objects around us only because light falls on them and it reflects. If light doesn't fall, it won't reflect, and if it won't reflect, we won't be able to see that object. Like what happens in total dark atmosphere. If it's everything dark around us, we can't see anything. That means there is no light falling on objects, we can't see them. So first thing, let's understand that reflection is necessary to get any object visible. And second and most important thing is that we have eyes to just get that spectrum noticed, understood by retina of your eyes, and then of course interpreted by your brains. So reflection is necessary, your eyes are also necessary to see the beautiful world around you. We will talk of this concept of reflection today. See, we know that reflection, that way it happens from all objects, but you can see your own face into a mirror, not into something like a board of this kind. So mirror bounces off light falling on your face almost completely. So 99% of light comes back and you can see your own image into the mirror. So when you stand in front of mirror, where is your image located then? Your image is of course on the back side of the mirror. And you also know that you cannot really go place a paper on the back side of the mirror and get your image onto it, because that image is not real. That is just virtual. Your eyes can see that image, but you cannot get that on any screen. As against some images can be captured on screen, but those are real images. But your plain mirror does not produce real images, it produces all virtual images. So mirror gives off or bounces off the light falling on it completely, and that reflection is called as uniform, regular, specular reflection. There are a variety of terms used for it. So it's a uniform reflection or regular reflection. And as you can immediately expect, there is term opposite to that, that is called as non-uniform or irregular reflection. Light falling on every object bounces off. But in mirror what happens? Just let's understand that if this is a mirror and if there are several light rays are falling onto it in a parallel method, then each ray will bounce off in a same parallel method in a parallel direction like this. So these are the rays coming and falling onto the mirror, and these are the rays which are reflected off the mirror. So there is definite kind of pattern of reflection because this is a regular reflection. And when we talk of irregular, as you can expect, on any object when light falls, it may fall straight, fine. The light rays falling would be straight, but they would get scattered in different directions. And of course this object will become visible because light is scattering or it's spreading in different directions when it falls onto it. Here of course the object will be visible inside as a clear sharp image. Like when you stand in front of it, light rays are falling straight from your face and naturally they are bouncing in the same direction, and you can see through your eye your own image clearly, because this reflection is regular reflection. I hope this concept is clear to you so far. But then as I just had drawn something on board, it is similar to what happens with a ball when you throw against a wall. When you throw a ball exactly in front of you, ball bounces, comes back so that you can catch it. But when you throw a ball in an angle like this, ball hits the wall and goes in some different direction again. It will never come back to you. Same is true with reflection in mirror. Angle of reflection or angle of incidence, first we'll talk of incidence, and angle of reflection with respect to some kind of perpendicular to that surface will be same. That is nothing but law of reflection. So that's the first law of reflection. Once again, if I go back, if I draw a perpendicular here, this is called as normal. Perpendicular to the point where the incident ray is hitting. So this is incident ray that is hitting. This is called incident. A ray falling on mirror. It will reflect off this surface in the same angle as that of angle of reflection, angle of incidence. So this is angle of incidence, angle of reflection. So these two angles are same. This is reflected ray. Incident ray and reflected ray with normal in the middle, making exactly 90-degree angle here. Now one more law about reflection, which is just a simple one. There are three things involved in it. One is incident ray, one is reflected ray, and one is normal. All three are in same plane. See, this is a plane. In one plane, this is a ray coming, this reflecting, and this is a normal drawn. All three are in same plane. So there are only two laws of reflection. Angle of incidence and angle of reflection are same with respect to normal one, and all three are in same plane. Okay, this is about concept of regular or uniform or specular reflection. Regarding irregular, there is nothing much to talk about. Rays get spread in all directions. Now I'll talk something about image formation inside the mirror. I'll just draw a mirror again. It is a mirror. Normally backside of mirror is shown in this kind of hash lines. If I place any object in front of it, I'll take a point object. Now you know there are several rays starting from this object, because this object is not a mirror, right? Let us take any two rays. If I take this ray, or if I take one more ray, starting from same point. Now these rays are falling on mirror, and you know they'll get bounced off following same law of reflection. That means I have to draw a normal here. So say this is a normal here. This ray will get reflected like this. Again I'll draw a normal here. This ray will get reflected like this. Now two rays, they are reflected this way. They will never come out together and they'll not create an image in this side. So what happens? Your eye, you are seeing from this side, looks at this object as if these rays which are reflected are extended behind the mirror. So if I draw these rays extended behind the mirror and they are going straight, second ray also reflected behind the mirror, and this will cross somewhere, and here these rays will, two rays which are meeting, we can take multiple rays, same will be the result. They'll meet here, and you will get image of this object behind the mirror at this position. If you really consider this distance and this distance are just same. Distance of reflected image, distance of object, if I call it. So they are same. This is nothing but the way image is formed in a mirror. So if you place this object somewhere here, image will be somewhere here. Depending on the distance of object in front of the mirror, image distance will be automatically be the same. Okay, this is about image, the way it is formed in plane mirror. Now if instead of one mirror, if I use two mirrors, now something very interesting would happen. See, if I take one more mirror this way, one more mirror this way, this is the object. What happens is, this will form more than one images, because the image which is formed inside one mirror and inside this mirror as well, if the angle is less, then these images will be formed this way, and it will once again create image on this side, and there are multiple images created that image becomes object for next image, and this image becomes object for this image. So there are multiple bouncing of light, and you get multiple images of one object, and depending on this angle, that will also change. I'll just draw it in a simple way. Two mirrors and one object in the middle. Image is formed. This image gets bounced off, this image gets bounced off, and you get multiple images. And this angle will decide how many will be the images created by this pair of mirrors. And how to decide that? It is very simple. You know this angle between two mirrors. I'll just write angle, or I can write it as theta. So it depends on angle between two mirrors. And the formula is, it's 360. You know, it's a total angle of a circle divided by theta minus 1 is equal to number of images. Using a pair of two mirrors, making angle of theta between them. That's the formula. To know it further, if I take angle as 90 degrees, this will be 90 then. The division will be 4. 4 minus 1, there will be 3 images. If I take 60 degrees, again 60, 360 divided by 60, answer is 6 minus 1, 5. If I take 120 degrees, answer will be 2 here. So on. You can easily find out that 120 degree had 2, 90 had 3, 60 had 5. If you go for 30 degrees, it will be 11. That means as you keep reducing the angle between two mirrors, the number is increasing. Number of images formed is increasing. So if you continue this logic further, 10 degrees and so on, so you will find you will get multiple images, like 35 images for 10 degrees. And if you place two mirrors parallel to each other, straightway parallel to each other, then angle between them is 0. So it is 360 divided by 0. Say minus 1, that is okay, minus 1. That means anything divided by 0 is infinity, or the infinite number, and an infinite number minus 1 is again infinite, so you can't say it's 1 less than that. So it's infinite. So when you place object, the bouncing off of rays keeps happening, and you get infinite number of images in pair of such mirrors, placed like parallel to mirrors. So it's time for activities, and the activity is around same concept, using two mirrors, understanding changing number of images, and finally making them parallel, achieving that infinite number of images. Students, we will do an activity to see that how distance of object from mirror and distance of image from mirror are same. For this setup, I am using two candles. One candle I am placing in front of this plain glass. This is a plain glass. It is not something like a mirror. But when the object is very bright, like a flame, its image is created even in plain glass. You don't need mirror for that. So I am placing this plain glass into these two plastic strips with a kind of stand, and I am placing it here. Now the distance of this candle I can fix. Say I place it at 17 centimeters. Now what will I do? We'll just lit this candle. There is one more candle kept, that is on back side. Now what will happen when this flame is reflected through this glass? Being it's a glass, I can see through this as well. I'll see from this side, front side, and the wick of this candle, which is visible behind this glass now, I'll try to bring it exactly on top of this candle which is not lit by me. So I'll just move it back and forth till I find that this wick is appearing exactly on the top of it. See, it's just an appearance of that flame on top of this candle, just appearance. Then once I am sure that okay, the flame is on top of candle, non-burning candle, okay, experiment is done, then we'll measure these two distances and you will find that they are almost same each time. If you change this distance, this will also go far behind it. This happens automatically when you try to adjust flame on top of candle. So let us do the activity. Let us do actually light this candle and do the activity. Now look at the final setup. The front candle has a flame, but the flame is getting reflected through a plain glass, and the reflection is appearing exactly on top of the candle, which is at exact same distance from plain glass as that of the front candle. So distance of object, distance of image, they are always same. We have proved this using this simple experiment. This time we'll try to see image formation using two mirrors together. We have two identical mirrors. I'm placing them on each other like this, taking sellotape and making it like a hinge structure of these two mirrors. I'm placing 2-3 sellotape pieces. And now this can easily open and we can give different angle between these two mirrors. To check that angle, we have this paper protractor. I am placing it this way and let us start. So initially I will try to take 90-degree angle. So here it is 90, so I can start from this 50 and go up to say 140. So I'm starting from 50 and going up to 140. So this will give you 90-degree angle. So you can easily count 90 degrees and make it. We'll place some object in between these mirrors. Say if I am placing alphabet R. And then let us see how many images we are getting. You will find you get 3 images. One is in the center and 2 in these two mirrors. So 90-degree will give you 3 images. If I make it say 60 degrees, so I am taking 30 on both the sides, 60 degrees. And if I place this, you can place any other object also. You can easily count. This gives you 5 images. Or if I make 120 degrees, Yeah, I'm starting from 30 going up to 150. Once again placing same R in between, you can easily see it gives only two images. So as you keep changing the angle, you will find you can get different number of images. Like 2 for 120 degrees, 3 for 90 degrees, 5 for just 60 degrees and so on. So that is the way you can get number of images by changing angle. So now we will do one very interesting project, that infinite street light. I am taking the same two mirrors. Remove the sellotape from these two mirrors. There is a cardboard pre-punched box. So first thing what you will do is you will fold these on these crease lines properly. So this becomes, once done, it becomes a box of this kind. So make sure that it becomes a rectangular box. We apply sellotape on this joint, but this should be applied from inside out. So this will make box more stable if you apply sellotape inside out. So I am using this sellotape. But prior to this, there are a couple of steps. I'll do them first. You'll find there is a double-sided adhesive tape placed here, and on one surface, which is after skipping one, there is another surface which will come exactly in face of this, in the front of this. I have to paste this road. See if it is little bigger, then cut it, because you want that to be of exact size. And now this will fit here. So let us apply sellotape to this first. This is a road print where you can see there are some vehicles as if they are moving. So we have applied this sellotape. Now one more thing further, there is an LED given, white color LED. So you know LED has two terminals, one is longer than the other, longer one is positive, shorter one is negative. Just spread them a little bit. Spread these two terminals a little bit and insert these two terminals through. These two terminals should come up. So insert them here. So their ends come up this way. Two terminals come up this way. So you can make out this is positive, this is negative. And the bulb has gone into the box. Then finally you have to make this box ready. I am taking sellotape. Apply it from inside out. I am applying from inside and then bringing it outside. Do it from other side also. You may apply some more sellotape because this joint must be very good. But always apply it from inside outside so that this joint becomes really good. Okay, I have applied sellotape, so now I can make this box stand like this. It's a rectangular box. You'll find there are two mirrors which are to be placed on two sides like this. So mirror shiny surface will go inside. However, we want one small window in the middle of one of the two mirrors. A small round or square shaped window exactly in the middle. What I am doing is using this sharp point of one mirror, I am just scratching this area off. So this you may do for some time so that this becomes absolutely clean. There should not be any coating remain on this area. It should be absolutely clean. You will find that if you see through this, you should be able to see something in front of you very clear. It should not be hazy. So take some efforts and make sure that this coating is totally removed. Okay, so I have created this small window into this, so you can see through this, right? Now place both of them on two surfaces. While applying sellotape, make sure that sellotape does not come on top of this. So you have to apply sellotape from sides. From all sides you have to apply. You can use any method. You can have even cross sellotape like this. That's also fine. You have to ensure that there are no gaps and you cover it completely. So light should not pass from gaps. If they remain, you should seal them properly. Same, see, make sure that you are not covering this. On the other side, place other mirror. Again, its shiny surface goes inside like this, and you apply sellotape. So you are applying sellotape in a way that no gaps remain. So you have done enough now. I think this should be adequate. So this is placed. Two mirrors facing inside. So the box looks like this. Avoid gaps. Okay, now coming to its electrical part. Cell holder has two wires. Remove its insulation. It is already cut, so you can easily remove. Then roll these multiple strands in your fingers this way, so they become a single thread. Normally these wires are multi-strand wires. You must roll them in this way, like this, and they become these all strands come together making a single wire. Now you know red wire represents usually positive. I'll just remove everything from here now. So once again look, this is long, so it is positive, and this is short, it's negative. Now just take this wire, put your thumb on one end of it and just wind it around it like this. And furthermore, bend this in half, so this joint becomes a good and lasting joint. Same way, without allowing this wire to touch other terminal, hold it in your finger using your thumb like this and just roll it around this negative terminal like this. Just keep rolling it and bend it. So both the joints are perfect. They are not touching each other as well. No wire should touch each other. Now last part is using cells. These AA type cells are not given in the kit. So you'll have to get them from home. You know, negative of any cell should touch this spring. That is the negative of your cell holder. like this, and the other cell, again negative should touch this spring. So I'm placing it like this. And you know, the infinite street light is already there. There may not be a vision for you from here, but look into this small hole and you will see there are number of LEDs glowing as if on top of the street they are illuminating the street. So this is what you have to do, achieve infinite images using two parallel mirrors.